Okay, so let's proceed. So, like I was saying, so we have this y. This is not y. This should be f of x. We're going to introduce y a little later in the game. Okay, so we call, like I said, we call the set D the domain of the function. The number f of x is always going to be called the value of f at x, usually just read f of x. The range is all possible values of f of x. So again, this is just a quick review. Again, if you need a more detailed review, please feel free to leave a comment below, and I'll be more than glad to walk you through everything I'm saying. But this is the idea. I have a set. Let's call this my set D. All right. Then I have another set here. Let's call this set E. And I have an X, right? And then there's this rule that we're calling F, that carries this X and takes it to E to a specific point, F of X. That means, let's say if I had, I don't know, a B, it would carry this B, again, the same rule, and then take it to another unique F of B. That's the idea. That's really what I'm trying to communicate. So you basically always have a set of ordered pairs, right? Yeah, so that's the basic idea. I'm hoping there is no questions at this point yet, but if you do, please make sure you leave a comment below, and I'll be more than happy to get through it with you. So we get to have a quick discussion of functions that you've seen time and time again. But what we're going to do for these functions, we're just going to look at we're going to first define the function. We're going to look at domain and the range of those functions, just to make sure you get the idea. So let's look at y is equal to x. All right. If I write y is equal to x, so previously I was writing it as f of x, right? So now look at f of x as y. Then what kind of function this is a linear function, right? First of all, it's a linear function. So then let's draw it out. Let's get some good shapes. And then, oops. It's a whole struggle to get this through, right? And we can call this y is equal to x, right? Means if this is 1, then this is also 1. That's what it means. So then if I asked you, hey, give me the domain of this function. The idea, let me rewrite that just so it looks a little, let's even change up the ink, matter of fact, to maybe purple. If I ask you, give me the domain of this function, right? So domain, if you remember, is all the possible values of x. So what values of x can go in here, right? Is there any limits? I can put in 1, I can put 0. So it looks like this function would literally take any values of x. So I could say that the domain of this function is negative infinity to infinity, right? Then what about the range? So range is always the possible values of y given x, right? So think about the smallest x I can have, right? It's something very, very close to negative infinity. So I put negative infinity in this function, I should also still get the same exact value. So in our case, the range and domain are equal. Much later on, we're going to have a conversation about odd and even functions. I'm going to save that for later because I think that is such an interesting topic to talk about. So let's do another example. I'm doing easy stuff, guys. I'll leave the hard things to you. Let's talk about y is equal to x squared. You have seen this function for God knows how long. You've seen it over and over again. I think at this point in your mathematical career, you would know what this looks like. I am not an artist, but I'm going to try to draw this as close as. So it looks like this, right? These two should be even, but you get the idea. So then if I ask you, hey, this is y is equal to f of x. So let's make some note. This is, first of all, a quadratic function, right? Please make sure you review quadratic functions in case you forgot them. But again, we're here to talk about domain and range. So what's the domain? It doesn't, like, if you look at the domain, this is the x-axis, right? This is your x-axis. This is your y-axis. Domain is all possible values of x. It looks like there is literally no x that can't go into this function. So I'm going to say that this domain is from negative infinity to infinity. But now when we come to the range, I want you to notice that this graph doesn't have anything in the negative y, right? Because if you think about x squared, if you put in -1, it's going to square it, so it becomes 1. If you put in -2, it becomes 4. So this guy would actually start from 0 to infinity. And if I was a perfect artist, you would probably see that this is actually starting from 0 and it goes all the way to infinity in either direction. Again, this is what we call a concave up function. Don't worry about it. We're going to get into more detail about it. But that's the idea. So a quick exercise that I'm just going to leave with you guys. Find the domain and range of, first thing, y is equal to x to the third, right? Naturally. The second one I want to give you is y is equal to the square root of x. So try out these two. It's really, really helpful if you graph them. Again, the idea here is we're just trying to get you familiar and to recall the things that you learned in pre-calculus. And once you're settled, we're going to take a deep dive into AP calculus.